So we're going to be splitting the first section of Chapter 1 into 2 days worth of videos. This first section is all about analyzing categorical data. So in our last video we talked about the difference between categorical and quantitative data, and today we're focusing on categorical data. These are the main objectives after this entire section, but after this particular video you should know how to at least interpret and construct bar graphs and pie charts. We're going to spend some time actually making them in class, and then also talking about the difference between good graphs and bad graphs. Now, when you collect your categorical data, you might ask people, oh, what's your gender? And they'd either say male or female, or as seen in this example, what's their favorite course, their favorite subject. And instead of just listing it all out, you can kind of summarize it into a distribution. We talked last time about a distribution and what that means, how it shows you the values and how often they take them. So the distribution of a categorical variable lists either the count or the percent of individuals who fall into each category. So you can see we have two distributions here. The one on the left-hand side just shows you the counts for the favorite courses, and the one on the right shows you the percentage of the individuals that liked that particular course. It should be pretty obvious how you would find the counts. You would just tally up how many are in each category. To find the percentages, however, you have to do just a little bit of math. So what you would have to do first is you would have to sum up all of the counts to figure out how many are in your group, how many individuals. So do a little quick math here. 8, 4, 11, 15, 12, that should add up to about 50. And, well, what percent of 50 is 8? That would be 16%. Your percentages should sum to 100 if you did your math right. Now, these distributions have more particular names. The one on the left is called a frequency table. Frequency is just another name for the counts of each category. And then the one on the right shows you the relative frequency table. Relative frequency shows percentages for each category. And the way that we found those percentages was by adding up the counts and dividing each count by the total and then converting it to a percentage. Now, if you have categorical data, you can display it in either a frequency table or a relative frequency table. Sometimes it's better, though, to display it using a visual. A visual aid is always a good thing to do in statistics. So, the best ways to display categorical variables are either using pie charts or bar graphs, sometimes called bar charts. So we've got pie charts. Some people call them circle graphs. We typically say pie chart and bar graph in statistics. They are good representations of the distribution of categorical data. Okay. On our next slide is an example of a bar graph and a pie chart based off of the AP scores for our school for Eastern Mennonite last year. And you can see how they did. They tell you different things. The bar graph is a representation of the frequency table. The pie chart is more a representation of the relative frequency table, since this tells you the percentages for each category. Notice how they're very accurate. Everything is labeled, easy to read. Now on your notes, obviously it's not in color, so you may want to add on your notes so you can see which color goes with which slice in this pie chart. Okay. Now, these are two great ways to show categorical data. However, pie charts cannot always be used. Pie charts can't always be used, okay? And we want to talk about why that might happen. So I want you to think about what a pie chart tells you, what a pie chart shows you, besides the fact that it shows you percentages. In this example down here, I'll just read it for you. Portable MP3 music players, such as the Apple iPod, are popular but not equally popular with people of all ages. Here are the percents of people in various age groups who own a portable MP3 player according to a survey of some selected people. This data could not be displayed in a pie chart. Why? I want you to think about that. Maybe jot down some reasons on your notes, and we will talk about that tomorrow. Why can't we use a pie chart here? Why wouldn't it make sense? Why might statisticians prefer bar graphs as opposed to pie charts? So looking back at that last slide, why might I want to look at this data in this format, in this display, versus in this one? What might be the advantages there? So jot down some of your ideas, and we're going to discuss those in class tomorrow. Now, when it comes to graphs, the thing I love about statistics, this slide kind of says it all. There are three kinds of lies, damned lies, and statistics. Statistics can be very manipulative if you know what you're doing. So, we're going to be talking about good and bad graphs, like deceptive graphs. What do they look like? How do we spot them? Now, here's an activity for you to do. This is an actual ad for DirecTV. There are multiple problems with this ad as far as it being a little bit misleading. I want you to jot down as many as you can. What is wrong? What are the problems with this advertisement? So if you need to pause the video, take some time, write down write down what you see. And we will share these in class tomorrow. Okay. A couple more deceiving graphs. I'm going to scroll through them. You don't have this on your note page, so you may wish to print out the slides for this that are on PowerSchool, just so you can have these if you also want to have them in your notes. These graphs are deceiving. It has to do with the way that it's being visualized. Notice how it's kind of like a bar graph, but they didn't use bars. This is what's called a pictograph. You see this a lot in elementary books, I feel, and then also in advertisements that are trying to be tricky. Alright, so here's a bar graph, so they didn't use pictures, so that should be better. But why is this misleading? Why is this deceptive? Notice your vertical axis here starts at 5. If we were to compare this, where my axis starts at 0, the difference between the three schools doesn't seem as dramatic as it does on the graph on the right. So some things to think about. Another problem, when it's three-dimensional, it plays tricks on your eyes. Another thing, look at where your axis starts. This makes it seem like unemployment rates were much, 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 much higher, when really, if you compare just the numbers, not so bad. So, some ways to detect deceptive graphs. Look for scaling problems, or if the axis doesn't start at 0. Another thing to look for, three-dimensional graphs, pictographs. They play tricks on our eyes. Look for proportional areas. So, bar graphs compare silver quantities by comparing the heights of bars that represent those quantities. Our eyes react to the area as well as height, so that's why your bars need to be equally wide. And avoid that temptation to replace the bars with pictures, because that can be misleading. Tomorrow we're going to look at some more misleading graphs. So, that ends our video for today. Make sure you have all of your notes filled in and you've written down your ideas. And we will practice making our bar graphs and pie charts tomorrow, as well as looking at some deceptive graphs.